Cool. So coupling. Let's have a look at an example in code. So I've given you some examples of non-code of a tightly coupled, loosely coupled systems. Does anyone have any better analogies in their head for this? Given my examples of a blender and my Mac Mini, can anyone think of any other examples?
I'm not sure if someone's going to hate me for this, but
hate me for this. Well, that's quite strong. Good start, Ramiro. Go ahead.
So a loosely coupled system would be like Power Rangers when they stick all together, and then a coupled system would be like Transformer, where it's just the whole thing.
Yeah, I think that makes sense, in the way that you described it. Any other examples that you don't think I'll hate, or you'll think I'll hate?
So I was thinking if the blender came with the vegetables that you have to use in the blender and you can only use those vegetables, that would be even more tightly coupled.
Yep. Imagine if it came with a house as well. So then you get the blender, it's the whole house. Yeah. Absolutely.
Say like the air fresheners, the plug-in air fresheners, the Airwick ones, because you have to buy the refills have to be Airwick, can't be anything else.
Cool. So there's some loose coupling that you can actually switch out the canisters, right? But it's still tightly coupled to the brand. You can't change the different brands, right? Yeah. And in the same way that the same thing happened with plugs and sockets and things like that for like tech products. There's a whole bunch of different chargers, and they try to find a way to remove that coupling between brand and charging cable to define like a USB-C interface. So most tech products getting there now are using the same interface. We've removed that coupling, even to the consternation of some of the brands who say, "Oh, so much more waste and whatnot." Blah blah blah. Anyway, so yeah, so this concept is not new. It exists everywhere, and usually loose coupling is better than tight coupling, especially in software. So let's have a look at an example of a very simple example of what this could look like. That is my randomizer. I'm in a directory here with just an empty JavaScript file. I'm gonna write some JavaScript, and let's have a look at what an example would look like of something that's like more tightly coupled than not. Okay, so let's create a class called Note. The purpose of this class is going to have some text in it. So let's use a constructor function to initialize my each instance of this class with some text. So I'm going to pass in the text via the constructor. It's going to be quite straightforward. So if I want to use this note, all I need to do is do something like this. So line 8 creates an instance using the new keyword. It creates an instance of the class note. In order to use it with some initial state, I'm going to use my constructor function and pass in an argument and store on the property called text. So let's say, hi, folks. And if I wanted to see this in my console, let's do console.log note.text. All right, quite straightforward so far. Before I run this, anyone want to ask questions about these 8 lines of code? Anything confusing? Anything you want to ask questions about? Anything that you're curious about?
So could you just run through that quickly again?
Which part?
The whole thing.
The whole thing. Cool. Okay, so we've got a class here, class note, and we have a constructor function. A constructor function allows me to create instances with different initial state. So for example, I can create a new note with hi folks. I could create a new note with goodbye. Different kinds of initial state. I can pass in different things, right? Because I've got a placeholder text and I can store it on the property. All right, so if I could log these two different notes, and they have different text values. Hold on. Hi folks, goodbye. All right, and so we have the ability to use a class. It has a construct function that I'm using one argument to store the value on the property this called text. So far, so good. Cool. I'm sorry, I can't see everyone's thumbs because you're all on. There's only 5 faces I can see. Nico, Ben, Grant, and Colin. I think you're the faces I can see at the moment. Plus my. Okay, so line 7 and 8. I'm using the new keyword to create an instance of my class note, and accordingly, I'm using an argument to pass into the constructor to set up initial state. So the constructor initializes it with different starting values if I need to. Create 2 variables to hold those 2 different instances, and then I'm using them to log the text value. Now, imagine if I wanted to format my text. Let's add a function here to format it. Let's say, let's format it. Let's use HTML tags. If you're not familiar with HTML tags, you don't need to be familiar with it. I'm going to add some text to the beginning and the end of this string in the HTML format. So let's imagine I've got another class to do this work for me. Let's say I'm going to initialize it in this method. So something like let's start with a paragraph. So let's do something like paragraph is going to be a new instance of my paragraph class. Paragraph formatter, let's call it that. And then let's go to do some work for us. Let's say something like paragraph. This is will be an instance of a class. I'll write it in a second. Let's say format and then this.text. So I'm going to use the value of my notes. I'm going to pass it to the format method of my paragraph class, my paragraph formatter class, and let's just return whatever that does. Okay, I have written my paragraph formatter, so let's go ahead and do it. What does my class paragraph formatter look like? Paragraph formatter. All it's going to do is have this format method. Format. It's going to take in some text, and it's going to return p text p like this. So the whole purpose of my paragraph formatter is it will just add the opening and closing paragraph tags to a string. That's all it does. So let's create again my 2 notes, and then rather than call text, let's call format. So my format method is going to create my paragraph formatter. It will format the text and return the value. Let's run it, and then I'll pause for any questions. Paragraph formatter. Oh, I've got a missing something somewhere. Unexpected token, opening bracket on line 12. It doesn't like this because I can't do that when I write a class in JavaScript. Boom. Okay, paragraph. Hi folks, goodbye. So I've managed to get my two classes working together. Create it with my node with initial state, hi folks. I create my second one with goodbye. And then I'm using a second class to do some work. In order to get that to happen, inside of this node, format method, I create my class, I execute one of its methods, and then return the value. Okay, let's see this side by side. So let's pause here for thoughts and questions at the moment. What do you want to talk about? What do you want to? What are you confused by? Let's pause here for any questions.
All right, sorry, I've got one question. So you've created a class called paragraph formatter, and then on top where you've consted the paragraph, that one's got the new paragraph formatter with the two brackets, but the other one doesn't. Is that why is that?
So I just want to clarify what you're asking. You see here that paragraph formatter has the sort of invocation of the bracket, right? And what's your question about that?
Is why that one's got the brackets on it and then the class paragraph formatter doesn't.
Over here.
Yeah.
So this is just a way to write a class. You just go use the class keyword, the name of the class, and then you're opening curly brackets.
Mm.
If you want to create an instance of the class, you actually don't need these, but it's good practice too. So you can just use new paragraph formatter like that. Okay. But if you ever want to pass arguments to your constructor like this, then you have to use brackets.
I see.
So to create an instance of a class, you use the new keyword and the class name. And then if you want arguments, you have to use them within brackets. Does that help?
Yeah, yes, thank you.
That's a good question. More thoughts or questions?
My question is, assuming you want to export the function of the class, if you export the node class, would you get the functions of the paragraph formatter?
And so your question is, if you export the node class,
yes,
do you get the functionality of what, sorry?
Of what the paragraph formatter has. Because are they going to be like separate classes with separate functions in them?
Yeah, they are. They are separate classes, separate functions, right?
Yes.
If this definition wasn't here, we'd get an error because we wouldn't know where to get the definition of paragraph formatter. So I'd have to import or require my paragraph formatter into this file.
Yeah, so now my question is, if you want to export the function of, let's say, the paragraph formatter, and then the function of the class nodes, how are you going to export both of them out?
So I can just export my node class, but if they were separate files, I would have already required my paragraph formatter.
Okay.
So it would look something like whatever this is, path to file. Yeah, so wherever my paragraph file, my JavaScript file is, we just require it. This wouldn't be here, and I can export my node class. Yeah. So because I've required it, my node now has a definition it can look up, so there's no errors with a reference error on line 9. And it can be exported, and it will hold that information within that exported node.
Yes, I'm talking about when you have two classes in the same file.
Mm-hmm.
You still just export the node class since technically it has a paragraph. Oh, okay.
Yep. I can also do that, and because it already has the method definition, it would still work absolutely fine. Yeah.
Thank you.
No worries. Good question.
So I was thinking, it seems like you've written loads of code to do a simple thing like creating the class paragraph formatter seems superfluous, but is that for like scalability or?
Yeah, where possible, always think in objects. All right. So even if you take simple classes, I don't want to see functions hanging out by themselves. So classes by default, where possible. And this is part of encapsulation. We want to be able to encapsulate functions, similar behavior within a class. Then it's thinking about responsibility. Where should the responsibility be? It should be in a separate class or in the same class. And for the purpose of this exercise, I'll give you a separate class, because really it should still be in a separate class anyway, because node should just be about the text, and the formatter is not the responsibility of the node. That's a separate conversation. I always want to focus on, at the moment, making sure we understand how we can use two classes together. I'm using one class inside of the other. I have access to its methods at the moment.
Sorry, Ed, you mentioned encapsulation. In this case, what function are we encapsulating here?
That's a question I'm going to ask you.
Well, I would guess, I'm not sure. Maybe it's the paragraph formatter, since technically it's the only one that's hidden in the class. I'm guessing. Not sure.
So we think about encapsulation. Encapsulation is an idea of two parts. One, where we are grouping similar behavior. Behavior is an idea of methods. Methods return values. Methods change something to something else. All right, they are functional. You input something, you get something out, and that is what we call behavior. So we're trying to group similar behavior together so that you're not looking at very disparate behavior in one class. Bits of similar behavior belong in one class, and we'll get a better sense of what similar behavior means in time. All right. So that's one part of encapsulation, grouping similar behavior. Another part of encapsulation is figuring out what is the public and private interface of an object. But let's put that to one side for the moment. In terms of encapsulation, classes are a very convenient encapsulation vehicle. We can use classes to package behavior. So in the node class, I'm just encapsulating the text. The class is responsible for its text. Doesn't need to know about what format it belongs in, it just needs to know about its text. But I can call format and then get other classes to do that work for me. Where the formatter class is responsible for just knowing about specifically that it's a paragraph. And that's the simple design at the moment.
Thank you.
No worries. So just make sure that you're feeling okay about using another class within a class. I'm instantiating the paragraph formatter within class node, within the format method, and accessing its method. Right. So what happens if I want to change it? What happens if I want to say, actually, I don't want paragraph, I want a heading value 1. If I want to change it, I actually have to change my node class as well. All right, so imagine I've had a second class here. Heading 1, let's just call it heading formatter to avoid numbers in my class names. Let's have the same format method, text, and let's return same thing as this, but with h1. All right, so I want to use my heading formatter in my node. So I now want to format my let's say my second note. I want my second note to be a heading and my first note to be a paragraph. How am I going to do that? Because I've tightly coupled my note to my paragraph formatter. Anyone got any ideas?
I was thinking you could add another constructor when you, so new note hi folks comma paragraph, new note hi folks comma heading.
So pass it in through here.
Yeah.
So this is definitely one option. And so how do I talk me through this? What are you thinking?
So then when it gets to the formatting, if you have this dot, I don't know, type equals paragraph or heading, then you could have a switch statement in your format or something.
Okay, so let's explore this. This is going along in the right direction. Let's keep it a little bit more simple for the moment, and then we might get to using the constructor so we can see that progression. What I think Grant's talking about is finding a way to store the information of what formatted to use as late as possible, all right, rather than inside the format class, as late as possible. So let's start off looking at this function format. Rather than instantiate the formatter here, maybe we could use it in the format method. So maybe we could do something like, let's decide what formatter we're going to use as an argument to the format method. So then we don't actually need to worry about this line. We couldn't just say, whatever is the formatter, get it to do its work. We're not going to care. We're going to try and remove that coupling to care about which formatter it is. As a result, if I'm changing this method here, I have to change it here. So let's say this will be the paragraph formatter, and this will be the heading formatter. So if I'm using it down here, I still need to instantiate it. So where am I going to create my instance? Well, let's just create it beforehand. So let's do const paragraph formatter. And the same thing with yeah. So let's take a second to read through this. The change that I've done is rather than keep it hard-coded, the definition of the actual format that I need on line 7, I say, actually, I want to remove that coupling, pass it in as an argument instead, formatter, and then rely on the formatter to have a method called format to then do its work. So I no longer care about which formatter it is. Just say, give me a formatter, and it will format. So I'm trying to find a way to decouple note from my formatting, from my formatters. So as a case, I need to still figure out which formatter to use, but now I'm doing it when I need to do it, which is when I run the format method. I'm saying run my formatter with the paragraph formatter or with the heading formatter, as you can see down here. Cool, so let's run it, see what happens. Hi folks, goodbye. You can see I've got two different opening and closing tags now. As a result, I can keep adding loads of different kinds of formatters. I don't have to change my note at all. My note is now sufficiently decoupled from my formatter, and if I need to extend this, all I need to do is add more formatting classes. I need to change or add any if statements or anything like that to my class note. Pausing here for thoughts and questions. What makes sense? What doesn't make sense?
This is better than what I said, because if you don't care about what format it's going to be in, you don't need to state it.
Exactly.
As well as what you just said.
Other thoughts and questions? What's going through your heads?
Would it be good to have a superclass here, is what I was thinking.
Let's not worry about inheritance. I'll say this probably a bunch of times, but where possible, never use inheritance.
Okay.
We'll talk about that next week. Inheritance leads you down bad paths. Prefer composition instead, all right? Okay, park that in your brain, we'll talk about it next week. But I like that you're already thinking about that. Anything else in terms of this example at the moment that you want to pick out? Because I'm going to ask everyone to pair up and do some exercises on this in a second.
Would it be, because you said, I think it was yesterday or something, where you should keep the classes in separate JavaScript files? Is that true for this as well?
The only reason I'm doing it all in one file is because I like to see everything in one place when I'm sharing my screen. So you're absolutely right. In general, the convention is one class per file. Good question. Anything else that you want to pick out about this? This is important. So this technique here is essentially trying to isolate dependencies, a class of entities. So note was dependent on the formatter, and we isolated it, and then we found a way to inject it. All right, we injected it using the argument here. So we're injecting our dependency via an argument. We found it, it was the formatting, and now we're injecting it through an argument. So really, this is down here is a technique called dependency injection. Right, this helps solve problems of tight coupling. Just making sure we haven't any more further questions, and I'll explain the task for you all to work on. Okay, so let's have a look. Explain what coupling is. This is the focus of this morning's exercises. Explain what coupling is, refactor code from tight to loose coupling. Information about running tests, linting code, intro. There's another example here that you can look through. Instructions. Install the dependencies for this project. Okay, so UI. Go away. Do I have this open? I do have this open. Okay, so this is your workspace that I want everyone to have a go at this morning. I'm going to split up into pairs. You can work through this together. The first step is make sure you've forked it or cloned it for this repository. Navigate to this directory called coupling. So you should be in this working directory, coupling. Then I want you to make sure that you've installed the dependencies for this project. The dependencies for this project are simply ESLint, so that should be fine. So make sure you install them using npm install instruction here. Then I want you to look at the move program in source move to reduce the coupling. The tests should pass once you've implemented it. So let's have a look at this. So let's have a look at source move. So this is some code that I want you to read and refactor, thinking about the idea of looking at coupling. And then after that, consider how to decouple your tests from the classes you use. So let's focus on this one first. And the coupling here, wherever you see a function, so we've got one move function, and it's not in a class at the moment. Not that it should be either, but it's just trying to keep things simple. We've got one move function that has one argument, and there's an if statement that looks at the vehicle and says, are you a skateboard? Are you a car? Or are you a plane? Or are you Superman? Then it returns a string, but the coupling here, as you might imagine, is the move function is quite tightly coupled to the class skateboard, car, and plane. Right? If you see a definition of another class in a function or another class, then that's a signal that there's some coupling going on. All right. Also, if it has to require lots of other classes, sometimes it has to. But that's also, these are all signals you can use. Think about how tightly coupled is my code. So I want you to find a way to remove the coupling. All right. See if you can get to a point where you don't need to rely on the class names. So success might look like being able to remove all of these and changing this method so it will work better. As a result, you might have to think about other classes. So the skateboard at the moment is empty. It doesn't have anything in it. So you might want to add more behavior to the skateboard, the plane, and the car class as a way to refactor it. So this is something to think about when you get into your pair. How can you remove the coupling? And the tests, let's run the tests. And node spec runner. So these are the current tests. Let's have a look at the specs. So we have these are all empty at the moment. You're just looking at the move spec. So the move source file and the move spec. And you can see it's written in a slightly different fashion. The test framework has been extended a little bit, so you can read through it or just not worry about it for the moment. The move spec still has an assert equals method, and it compares two things: the result of using your move function and a string. So currently, the output we have passing for a skateboard, car, and plane. And you want to add your spaceship to make sure your spaceship can move. But you might want to change this at some point to, once you've refactored your code, you might have to change this. So let's make sure that we understand what we're going to be doing. Install dependencies, refactor the move program in a similar way that we were doing before, thinking about where the coupling exists and how can we refactor it. And the test should pass once you've implemented it. Then consider how to decouple your tests from the classes used. So we might gather back and then have a look at that together. If you want to keep going, there's more examples here to think about decoupling the other two classes. There's an example for you to have a look at, but only after you've tried your hardest with it in the direction called solutions. Cool. Any questions about what you're going to be getting on with in your pairs in just a minute? Sound good? Sweet. Okay. So let's get the pairs up. Where is, there you are. How many are we? Let's do 9. Assign automatically, create. Cool. All right, any questions? Ping me on Discord and I will come help. Let's do a good 45 minutes. Let's gather back at 11, see how far you get. Any questions, let me know. Opening rooms.